Good afternoon, everybody. In this lesson, we are going to open up talking about our Internal Achievement Standard 2.14, which are systems of simultaneous equations. What we're going to be doing here is taking two equations, equation 1 and equation 2, and those two equations have two variables, or two unknowns. Those unknowns are x and y. And what we'd like to do is today discuss what's known as the elimination method. And what that involves doing, if we can take what is two equations with two unknowns and eliminate one of those variables, we'll have one equation with one unknown, which we know how to solve with our algebraic methods. Okay, one of the things we know about these lines, we know that equation 1 and equation 2 both represent the equation of a line, a straight line. And we know that because x is to the power 1. We know if x is to the power 2, we've got a curve or parabola. But since x is to the power 1, we've got two straight lines. And it's possible somewhere those two lines are going to cross. And we're looking to find the point x comma y where those 2 points do what? Intersect or cross or meet. So one of the things we can do is we can add equations together. Equation 1 and equation 2 can be added together, and that won't affect anything, except maybe eliminate a variable. And one of the things we know about these lines is they go on forever and ever and ever. They're infinite in length. So if I take something that is infinitely long, and I add something to it that is also infinitely long, what we're thinking is essentially infinity plus infinity is still infinity, so it's not going to have an impact. So let's try adding these together. Let's take equation 1 plus equation 2. 2x plus 3x is 5x. Negative 1y plus 1y, those are opposites. Negative 1 and positive 1 are opposites. So that's one thing we want to recognize. If one of the variables has coefficients that are what? Opposites, adding those together eliminates one of those variables. So 13 plus 7 gives me 20. Now I've got something that I know how to solve. 5x is 20, so x is going to be 20 divided by 5, or 4. Now I've got my part. My x is 4. And what I'll do now is I will take this value of x, plug it in to either one of the two equations to solve for y. So if x is equal to 4, 2 times x, so again, I'm going to take equation number 1 right here, equation 1, 2 times x, or in this case, 2 times 4 minus y equals 7. 2 times 4 is 8, minus y equals 7. And of course, 8 minus 1 is 7, so y is equal to 1, making the point where those two lines intersect the point 4 comma 1. And what you should do, just to make sure that is the right point, is substitute this into equation 2 to make sure it also comes out to be true. So 3 times x, 3 times 4 is 12, plus 1, y is 1, 12 plus 1 is 13, and 13 equals 13, so that solution checks. There is the elimination method by adding equations together. Good job.